Okay, so back to week 3, the second half of the lecture. It's going to be under part 2. So we left off with signs of numbers. Again, I know this seems a bit trivial to some of you, but it's extremely important that you understand this. If you have a problem that asks you again about different scenarios, and they'll give you options, Roman numeral 1, 2, and 3, this is where this will traditionally come up. Many of you know these rules already, but again, multiplication. If you have the same sign, it's a positive result. If the signs differ, it's a negative result. And the same thing applies for division. If the signs are different, when you're dividing two numbers, you get a negative. If the signs are the same, they cancel, you get a positive. Okay? Now, it's important also to know that when you take the square root of something like this, so if you have x squared is equal to 9, when you take the square root of both sides, your answer is just x equals, but again, the answer is plus or minus 3. How come it's plus or minus? Well, because if you square negative 3 or square positive 3, you get back to positive 9. Okay? If you have several numbers that are signed, again, this might seem once again trivial, skip this if it is for you. If you have several numbers that are all negative, okay, we'll notice here that it turns out to be a positive. Well, let's take a look. Negative negative yields a positive. This negative negative yields a positive. And then it's going to be a positive times a positive, which is still a positive. But if we see that we have it to the third power, this negative negative yields a positive, but now we're taking this positive times by this negative that was left over here, giving us the negative sign. The general rule of thumb for powers, in case you're wondering, okay, again, is if you have an even number of factors or an even exponent, so to the 4th power or to the 6th power or to the 8th power, even though it's negative, you'll get a positive answer. Again, if you're using your calculator for this stuff, like last week we talked about, make sure you put your number in parentheses and then raise it to the corresponding power, whatever that power may be, to the 3rd. Okay? Let's move on. So, fractions and decimals. Fractions and decimals, besides the fact that they're very important in real life because you see them everywhere, are also part of the test that gets confusing simply because it's either multiple choice or it could be grid-in. Again, on grid-in, on any grid-in problem, if you have a fraction or a decimal, either one are acceptable as long as they can fit in the boxes. But for a multiple choice, you might get as your answer, let's say your answer, you get 0.666666, all these numbers after a while, all these sixes. Well, most of us know that that's just 2/3. Okay? If you didn't know that, there's a way you can change your calculator, but we're going to also talk about how to do that today. Now, the issue comes about here. If you make all of these corrections, or if you make all of these operations, perform all these operations throughout a problem, and let's say you're rounding, you might get an answer that looks like this. And a lot of people right away are saying, okay, 0.6670124, okay. But this might have actually been 2/3 as an answer if you didn't round along the way. So you have to consider the fact that when you round, there'll be something called a propagated error. A propagated error just simply means that every time you round, you're actually accompanying a little error. And the more of those errors you have, the more incorrect your answer will be, or the more deviated from the actual accepted answer your answer will be. So for example here, this might have been an answer of 2/3 as your multiple choice, but this is what you got as an answer. Sometimes consider that when you're doing these problems, especially if you're rounding. If you're storing the data in your calculator, then you don't have to worry about that rounding. Now, to talk about fractions, we have proper versus improper. Okay, a proper fraction simply means the number on top is smaller than the bottom. Improper means the number up top is bigger than the number on the bottom. So here, we're going to be looking at if we have an improper fraction such as 3/5 versus a proper fraction of 3/5 versus an improper fraction of 6/5. Okay, so sorry about the interruption again there. Continuing. So first, proper fractions, again, the numerator is smaller than the denominator. Improper, the numerator is larger than the denominator. Improper fractions, you're going to see over and over again later in calculus and pre-calculus. There's nothing wrong with them. It's just that traditionally we write them as a mixed number. But again, improper fractions are used all over the place, so please don't let them scare you, just because the numerator is larger than the denominator. Now, equivalent fractions just simply means two fractions that happen to be the same number, but they might not be reduced to lowest terms. So for example, 6/8 and 3/4 are the same fraction. They're equivalent, but they're not in lowest terms. 3/4 is lowest terms, but 6/8 is not. So let's look at a quick example to start this one to reduce the lowest terms. We're going to see here for this example, it says write 16/24 in lowest terms. Well, immediately what you need to do is break that up into its factors. That's how this always works. So break the numerator up into 4 times 4 and the denominator into 6 times 4. Well, I can see right away that the 4's cancel and I'm left with 4 over 6, but clearly that could be reduced to 2/3. So maybe I didn't reduce it to the greatest common factor of each. So I might want to go back and say, okay, let's start that again. 16/24, I can actually break that up into 8 times 2 and 8 times 3. And now I'm going to see when my 8's cancel here, I'm simply left with 2/3, the exact same value that we had there. So whenever you're reducing something to the lowest terms, just think, take out the GCF of both the numerator and the denominator, whatever is the GCF of both of them, okay, the greatest common factor. As far as mixed numbers go, the general rule, okay, so a number like 3 1/2 really means, as many of you know, 3.5. But if you want to convert this back to a improper fraction, you might want to take this number, you multiply by the 3, and then add the 1. 2 times 3 is 6. 6 plus the 1 is 7, so this is really 7 over 2. And go ahead, type it in your calculator. 7 over 2, 3.5, exact same value. Let's look at another example now. If we'd like to convert an improper fraction into a mixed number, it's simply division. That's where our remainder comes into play that we talked about a little while ago. So here, for this problem, 7 goes into 66 9 times. So it goes in 9 times again. You could think of it this way. It goes in 9 times. 9 times 7 is 63, which leaves 3 over. So this is, 9 remainder 3. But if you remember from last time, we said remainder 3 means the 3's up here. The divisor is my 7 here. So I take the 7 and put that in the denominator. And there's your mixed fraction. Okay, again, your whole part is 9. Your mixed part is 3/7. We talked about this a second ago, but in case you want to see a formula to write a mixed number, you always take the denominator times the whole number part and add the b. Denominator times the whole number part, add the b, all over the same denominator. So again, if you have 2 3/7, this becomes, if you just use the formula, you'll see it's 7 times 2 plus 3 all over 7, which is really 17 over 7. Okay? Again, multiply the 2 and 3, the 2 and 7, and then add the 3 to that number afterward. So this example here, let's take a look. Multiply these two, you're going to get 44, add the 6, and then divide by the same denominator. So it's 50 over 11. Okay, 50 over 11. Why is it important to do this? Well, several reasons. On the grid-in, you cannot answer with a mixed number. So 4 6/11, you cannot grid that in. Now, turns out you can't grid in 50 over 11 either because there's too many digits. But if there were fewer digits, you could. So if you look back at this example, you can't grid in 2 3/7 as a fraction, but you can grid in 17 over 7. 17/7. Again, there's 4 boxes for the grid in. So we can grid that one in. Now, what you could always do as well is just approximate this as a decimal. Okay? Put your decimal value there and approximate. All right, let's take a look at our decimals now. First, I'm going to quickly go through some of this stuff because I know a lot of this is review to you guys, but let's just make sure we understand what's going on here. First, we're going to see that we have a number coming up. Okay, we have this number right here, 8,253.769. Okay, now just to discuss what every place is. 8, the first place. This is the thousand place. The thousand place. 2 is in the hundred place. 5 is in the tens place. And 3 is in what we call the ones place. Now, the ones place, a synonym, is called the units. The units place. Okay, units, be careful there. Now, going on to fractions, there is no ones place or units place. You start immediately with the tenths. Notice, it's not 10, like here, but tenths. And instead of 100, as we work out, we're going to work out toward hundredths. And then instead of thousands, it's thousandths. So it's the exact same number as you would, or the exact same word as if you're going to the left of the decimal. But now since we're going to the right of the decimal, you add the th on the end. So tenth, hundredth, thousandth. Again, emphasizing the th there on all of those. Now, if you want to think about how you compare decimals in your mind, okay, if you're comparing decimals, just simply list them. So if you had a number like 2.307 and 2.3, let's say 312, you might say to yourself, okay, which one's the biggest? All you do is work left to right. Same number, even. Same number, still even. Now suddenly there's a 0 here, but there's a 1 here. That one's bigger automatically. So again, work your way over from left to right, see which number is bigger, and you'll be able to figure it out. Now, if you don't have a number, what if you have, you say, okay, Mr. Howell, we'll take a look. You got 2.5 and 2.504. Well, the 2's are the same, check. The 5's are the same, check, we're done. Well, there's nothing left on the left one, but there really is. And many of you remember there are an infinite amount of zeros. So place as many zeros as you need. Same number still, and then we'll finally realize on the 4th digit that this 4 here is bigger than this 0 over here. So this turns out to be the larger of the two numbers. Simply going from left to right. Remember, if you have a decimal that terminates, you can always add as many zeros as you would like to the end of it. So 2.5 is a terminating decimal. I can add as many zeros as I want. No. We don't want to save the ink. Delete the ink. Okay. Next, rewriting fractions as decimals. There are many ways to do this. Okay, there are many ways to do this. I personally suggest to you right now, just use your calculator for the test. There's no waste. You should not waste your time doing this by hand. Now, if you have something like this, you should know by now that it's 0.6 repeating, or 1/5 is 0.2, or let's say, I don't know, 4/9. Our trick of ninths is that it's just 0.4 repeating. Anything that's a ninth is just a numerator repeating. So like 5/9 is 0.5 repeating, 6/9 is 0.6 repeating. Well, you say 6/9, sure, that's just 2/3. Yeah, it's still the same thing. 2/3, 6/9, 0.6 repeating. So some of these rules you should know. But like, for example, 15 out of 40, you might not know that right away. I happen to know that reduces to 3/8. Okay, dividing everything by 5, dividing by 5 in the numerator and denominator, reducing by a factor of 5. And 3/8 turns out to be 0.375. So that's a value that I happen to know. If you don't know your eighths, 0.125, 0.250, 0.375, 0.500, 625, 750, 875, 000. If you don't know all your eighths, don't worry about it. Go ahead, type in 3 divided by 8, or even just type in 15 divided by 40, and you'll get a decimal automatically. Again, unless you know the number right away, don't try and figure it out by hand. If you need to convert to a decimal, just use your calculator. Comparing fractions, again, same thing. I highly recommend convert to decimals and then compare the decimal representations. Dividing and multiplying by powers of 10. Okay, it's very important that we understand what's going on here. So if we look at scientific notation, this is like 3.45 times 10 to the third right here because of 3 zeros. This is 9.13 divided by 10 to the second there. Okay, so if we're looking at this problem, this is the same thing as writing that 3 is the exponent here, indicates how many spots I'm going to have to move my decimal. So I move 1, 2, well, 3 spots means I have to add a 0. So 3, 4, 5, 0. That's my answer right here. Here, since I'm dividing by 100, I need to move the decimal to the left because it's getting smaller. So this is really, you can read it that way, times 10 to the negative 2. Okay, or you can simply continue to read it this way. Either way, divided by 10 to the 2 or times 10 to the negative 2 still means move it 2 spots to the left. So either case that you've got, it's going to become, again, move the decimal over to here, add a 0 in, 0.0913, and that's the answer you get here. Same thing here. This dividing by a positive exponent, that just means the same thing, move it to the left. Okay. Let's continue to look at operations with fractions, so multiplying, dividing, adding, subtracting, all that fun stuff. Now, if you're ever going to multiply a mixed number times another fraction, or even a mixed number times another number, I highly recommend that you convert that mixed number into an improper fraction. Convert to an improper fraction. It will help you in the long run. Let's take a look at this problem. Before you ever do anything, please reduce the lowest terms and also cancel diagonally. Because what does this really say to you? This really says 4 times 5 over 9 times 8. which as we know from commutative property could be written as 4 times 5 over 8 times 9. And then most people see, oh yeah, this is just 1/2 here. So in the end, this ends up becoming 5 over 18. Okay, the other way to do this is to look initially. Cancel, cancel, put a 1, put a 2. You still get 5 over 18. Same answer either way. Okay, but remember you can cross cancel. But the idea for multiplication is you multiply across the top, multiply across the bottom. Now, finding a fraction of a number. This is a problem that comes up on every single SAT in some context or another. When you see the word of, you must replace it with a times symbol. So the question says, what is 2/3 of 15? What is 2/3? And many of you know right away, yeah, it's 10, that's great. 2/3 of 15 is 10. Where does that come from though? So let's take a look. 2/3 of means times 15. Well, you might say, where's the denominator? We're missing it. We can't do this problem. No, just put it over 1. Now you're going to notice you're going to get 15 and a 3. Those can cancel. Reduce, reduce. That's a 1, that's a 5. I'm left with 2 times 5 in the numerator, which is 10. 1 times 1 in the denominator, which is 1. Well, 10 over 1 is still 10. So when you see that word of, please go back and say to yourself, of means times. Of means times. So after John spends a quarter of his salary on food, 2/3 of it remains on clothes, what part of his salary does he have? So we have a variable here. We don't know the salary. So we'll say X is the salary. Again, what part of the original salary does he have left? We need to figure out what X is. Okay, we're trying to figure out what the salary is so we can see what's left. Now, we know that he spends a quarter of his salary on food. So food accounts for 1/4 of his salary. He spends 2/3 of what remains. Well, what remains after you use a quarter? After you use a quarter of something, you have 3/4 left. So clothing is 2/3 of what remains. Well, what remains is 3/4. Again, if you use a quarter of it on food, you've got 3/4 left. So 2/3 of what remains is 2/3 of what remains, 3/4 X. And it says, what part of his original salary does he have left? Okay, what part? So, we know that we lose a quarter of X to food. Multiplying here, we're going to cancel, cancel. 1, 1. This becomes 2/4 or a half. So a quarter of it is on food. He spends 2/4 of it now. 2/4. I'm going to leave it in quarters, just because common denominator. 2/4 of it on clothes. So altogether, between food and clothes, he spends 3/4 of his money. So what part of his original salary does he have left? He has a quarter of his original salary left. 1/4 of his original salary. Because again, he combines this quarter and this 2/4, showing that he spent 2/4 and 1/4, which is a total of 3/4 on food and clothing. Dividing by a fraction. Dividing by a fraction. Please multiply by the reciprocal. Your rule for this will always be the same, no matter what you do. Whenever you divide by a fraction, you must multiply by the reciprocal. It's a rule that you're going to use throughout pre-calculus, throughout calculus, and beyond. Whenever you divide by a fraction, multiply by the reciprocal. So in this example, the reciprocal of 12/7, yes, you're correct, is simply 7/12. So 3 divided by 12/7 becomes 3 times 7/12. 3 is really 3/1. The 3 and the 12 reduce to 1/4, and you're left with 7/4. Okay? Another way to write this, in case you're wondering, if you saw 3/12/7 like that, it's the same thing as this right here. So you say, okay, well this is just 3 times 7/12. So you multiply by the reciprocal still. Okay. This next thing we're going to talk about can be a little bit confusing for some people, and because it's misleading at first. So let's discuss what we're going to talk about. First, if a number is between 0 and 1, it's a very good fact to have written down. If a number is between 0 and 1, thus it's either a decimal or a fraction, okay, either representation, having to be a proper fraction, by the way, and you're able to square it, the number goes down, actually, and it's very misleading. And most people think when you square a number, excuse me, it has to go up. But if you square a fraction, just think logically. the example is simple right here, 1/4. But let's say we have 3/8. If you square this, it becomes 3 squared over 8 squared, which is 9 over 64. Now, 9 over 64 does not reduce. But if you actually turn that into a decimal, you'll see that that number is less than the original 3/8 that you began with. So whenever you're able to square a fraction that's between 0 and 1, you could think about the fact that it's going to get smaller. Now, if you take the square root of a number that is between 0 and 1, it gets larger. And again, think about it this way. If you had the square root of 1/4, the square of 1 is 1, the square of 4 is 2. Well, 1/4 went to 1/2. The square root of 1/4 is equal to a half. But a half is bigger. So the number gets larger when you take the square root of a fraction or decimal. Again, these are two properties that are only again, for 0 to 1. Okay, for 0 to 1. Anything bigger than 1 is going to be the opposite. When you square it, it gets bigger. When you square root, it gets smaller, like you've always learned. Quickly, adding and subtracting. This should be a review for everybody. Convert to an improper fraction. This becomes 9/4 plus 17/3. Clearly, those are not the same denominator, so I need to multiply this one by 3 over 3, multiply this one by 4 over 4. Okay, every time, whenever you're in doubt, multiply by the other denominator. You're left with 27 over 12 plus 68 over 12. Okay, simply 68 comes from the 17 times the 4 there. Excuse me. Now, going down, we add our numerators and keep our denominator. That's the whole trick here. Okay, well, not really a trick, but that's the common sense. Because if you think about it, if you had a half plus another half, you get 2 halves total, or a whole. Okay, you keep the denominator. So here you're going to have a 7 added on to 68 is 75, another 20 is 95. So your answer is 95 over 12. Again, you can then convert that back to a mixed number if you would like to. I'll leave the subtraction one for you to try on your own. Same rules apply, except now you're going to subtract the numerators once you get them to be common. Simplifying a complex fraction. Simplifying a complex fraction. Well, let's take a look at this one. Here we've got 4 over 1 over 3 over 2. Okay, 4 over 1 over 3 over 2. Well, this is crazy looking here. Okay? First thing you want to do, again, is just think of everything. Okay, think of everything as a horizontal division problem using a division sign. Okay, use a horizontal division sign. So here I've got okay? So the easiest way to do this is just simply look at the problem. Go across here. We're going to have 4 divided by 1 is 4. 4 divided by 3 is going to be 1.333. That number divided by 2 is just going to be 0.66 repeating. Now, the problem comes about when you have stuff like this now. What if you have 2/3 over 3/8? Now you don't want to just go through it as a division problem, but simply multiply by the reciprocal. So write this as 2/3 times 8/3, yielding 16 over 9. Okay? Again, multiply by the reciprocal there. Multiply by the reciprocal there. Let's see, what else for this one? Anything else I want to discuss? No, it's good for now. All right, let's take a look at fraction word problems, please. Let's take a look at fraction word problems. So this is another one where we have parts out of wholes. So the first example says if there are 15 boys and 12 girls in a class, the number of boys is what fraction of the total number? Very simple. Okay, the number of boys is the total of what fraction? So there's 15 boys, 12 girls, yielding 27 total. So what is the fraction of boys? 15 over 27. Again, very low level problem. Reducing by a factor of 3 everywhere becomes 5/9. Okay, this would be more of an easy problem in the SAT. Easy problem. Now is the harder problem coming up next. If you're given some sort of a fraction, you have to figure out what the whole is. Okay, and part of it is known. So if 4/7 of some unknown number is 12, okay, and then multiplying 12 apart by the reciprocal of the given fraction gives the whole number. let's go through an example of this, because this problem is a little bit, that statement is a little bit too vague here. Of the books that are on the shelf, a third are math. So a third are math, that's important. A quarter of them are science, that's important. And the remaining books are history, that's also important. If the shelf contains 10 history books, how many books are on the shelf total? All right, fair enough. So it's a third of the books, a quarter of the books, the remaining books. So let's call the total books, let's say instead of X for this one, let's use N, does not matter. N is the total number of books. So that means that math is represented by a third of the books, science is represented by a quarter of the books, and history, we said, is just simply 10. There's 10 history books. Sorry, there's an N there. So the math, again, this is our let statement right here. It's our let statement. The math books are represented by a quarter of the total, a third of the total. The science books are a quarter of the total, and the history books are 10 total. So we are able to figure out, okay, well, how many books are there total? N is the number of books total. So we could say a third of N, which is math, plus a quarter of N, which is science, plus the 10 history equals the total. Again, where does this actually come from? Math plus science plus history equals total in this problem. Okay, solve for N in this problem. How can we solve for N here? Common denominator is one way to do it. We can do it that way also. I mean, multiplying 4 and 4 here and here, 3 and 3 here and here. You're going to get 4 over 12n plus 3 over 12n plus 10 equaling n. Common denominator is the 12, so you can get 7 over 12n plus 10 equals n. I'm going to continue up here. Subtracting 7/12 n from both sides gives me 10 equals 5/12 n. Multiplying by the reciprocal to get n by itself, we're going to multiply both sides by 12/5. Again, because you would divide normally by the fraction, but we can say multiplication by a reciprocal. You get n by itself. 10 over 5, reducing, is going to give me 2 and 1. I get a total of 12 books. Not 24 books, 24 books. 12 didn't make sense. Total of 24 books because of the 12 times 2. Let's take a look and think and make sure that makes sense. A third of the books are math. That gives me 8 for math. A quarter of the books, a quarter of that is 6. And then history is 10. 8 plus 6 plus 10 gives me a total of 24 books. Okay, it does work out. Let's continue onward. Okay, percentages. Percentages are pretty straightforward because of the word itself. Percent. Per means out of, cent 100. So it's out of 100. Now, my recommendation for you is, first of all, know what that means. How do you actually write that? So if you ever want to write 85%, you start by writing it as 85 out of 100. And then once you see 85 out of 100, you can realize that's 85 hundredths. And that's how you would write that. Now, converting decimals to percent, you simply move it 2 spots. Simply move it 2 spots. Simply move it 2 spots. Okay? If you're converting from percent back to decimal, you would have moved it 2 spots the other direction. Again, a percent is really out of 100. So when you see 0.56 like this, you're thinking that's really 56 hundredths. That's how you would say that as a decimal. Well, 56 hundredths is really 56%. That's what a hundredth is, percent. So those 3 things are all equivalent to one another. Now, as far as a fraction goes that's in lowest terms, if you want to write that as a percent, just go to your calculator, type in 3 divided by 4. If you didn't know this, you should know this though. If you didn't know, it's 0.75, you get that. And once you know it's 0.75 as a decimal, move it 2 spots over, and you get 75%. Okay. Let's take a look at this next example. To find the percent of a given number, okay? So what is 15% of 45? So 15% of 45. So again, this is where it comes into play. Before, we talked about the word of. The word of in math means times. When you see percent, it means out of 100. So now we have something out of 100 that's multiplying. When something out of 100 is multiplying, we can think of fractions. If we start by reducing, it makes this problem a lot simpler. Reduce by a factor of 5. You're going to get 9 out of 20 here. once you have the 9 over 20, you can then see that, well, okay, 15 over 20 is really 3 over 4. That reduces further, which yields just simply an answer of 27 over 4. Okay, well, you might say to yourself, what is that as a value? Well, it's just really 6 1/4, or 6.25. So, what is 15% of 45? It's 6.25. Again, of means times. Of means times. All right, the next one, I'd rather you not memorize the formula. I'd rather you not, but you could remember if you want to. That's the amount of change over the original amount. That's percent change. So let's take a look. Again, amount of change over the total amount. So the price originally was $70. The new price is $84. So what was my change in price, my delta price? My change in price was a positive $14. So that means that I went up $14 on top of my original 70 that was there. So I need to figure out, well, what is this? I can say to myself, let me reduce. Reduce by a factor of 7, please. This becomes 2 out of 10. 2 out of 10, though, is 1 out of 5. 1 out of 5 as a decimal is 0.2. So what's the percent increase? What is 0.20? 20% increase. If you know the amount of percent increase, and you want to find out the original amount, okay, the original amount, there's several formulas you can use, and I wrote them down because you've seen these all over the place. You've seen these in Algebra 1, but we're going to go right to an example here. So let's take a look. A pair of jeans costs $48.60, including sales tax. If the sales tax rate is 8%, what is the cost of the tennis shoes before tax? So here's what I want you to think about. $48.60 is the price with tax. So this does not represent the normal 100% of the item. It does not. It represents 108% of the item. Again, 100% of any item is the actual price. If you add on 8% tax, now you're looking at 108%. The simplest way to solve these problems is actually by a proportion. So I would say that 48.6 over 108 is equivalent to x over 100. And what this tells me is that 48.60 is representing the 108. Well, what represents 100%? Or the price, 100% is the price before tax. Okay, the price before tax. The price before tax. So if you cross multiply and solve, we can get a solution for this one. Let's quickly take a look. We're going to have 100 times 48.60 equals 108x. This is going to become 48.60. When I multiply those two, equals 108x. Divide by 108. Divide by 108. So again, 48.60 out of 108. Now, when you get a value for that, you're going to get an answer. I sure hope your number is less than the actual value, because again, we're trying to find the cost of the tennis shoes before tax is added on. So it's got to be something less than 48.60. Okay, that concludes the Week 3 video. Week 3 video, again, was primarily Chapter 1 notes, all the notes from Chapter 1, these 12 pages that we just looked through. Your homework this weekend, or your homework this whole week, is to work on all of these practice problems. So, if we go back to our syllabus to take a quick look at what the homework is, again, we did Chapter 1 just now, in 2 parts, I know. You need to complete and read the strategy sample quiz, page 4 to 6 and 12 to 15 this week. Last week we did 1 to 3 and 9 to 11. There's also a Chapter 1 quiz that you can work on based on what we just did, and there's also another practice section. Okay, to see what those look like real quick before we quit here, we'll see that the Chapter 1 quiz looks like this. It's all multiple choice in the beginning. You're going to see a lot of multiple choice problems here, and some of them are tricky. And then eventually you're going to see that the last few of them are going to be grid-ins. Okay, so again, practice these this week. At the end of the week, I'll put the solution up. On Friday, the solution will go up for this. The other practice section I want you to work on is another practice section out of the sample test booklet. Okay, so please go ahead and take a look at this. The solution of that will be up later in the week as well. Again, your homework this week, 3 things. Spend some time each night working on these, and you'll have no problem over the weekend cramming. Again, please break this up. Work on this tomorrow night, Tuesday. Work on this Wednesday. Work on this Thursday. By Friday, you can check all of your answers for these 2 with the solutions that I post. You can always check your answers to these 2 because pages 12 to 15 are the solution. Next week, which is week 4, will be Chapter 2. Okay, we'll start that next week. Again, have a great week. If you have any questions, please ask any of your math teachers.